Hey guys, we're going to go over the chapter 8-9 study guide sheet for proportions. So again, the reason why this is kind of straddling two chapters is because we did both a confidence interval and a stat test. Chapter 8 is confidence interval and chapter 9 is a stat test. Okay. So let's get all of our information on our cheat sheet. This will help us keep track of my all the stuff I need, right? Okay, so when you're only doing one proportion, the letter P stands for your true proportion of all the people you're interested in making an inference about, whatever that is. So it's all people who take the vaccine from Johnson & Johnson, right? Whatever it is you're wanting to make an inference about. And what your sample would be was, let's say you took a sample of 100 people, that would be your sample proportion. So you want to know the proportion of people that had side effects, but you don't want to ask every single person. So you just want to take maybe a sample of 100 people. That's your sample proportion. And the name of this procedure is a one sample z-test. And then in the previous chapter, we called it a one sample z-interval, right? So we're not changing a lot from the last test to this one. And again, I'm trying to make a connection between the two. Okay. Now, would this be the same if I did it for two? So maybe I'm interested in the proportion of people that have side effects, but I want to kind of compare men and women and see if there is a difference between men and women. If I took the difference between these two groups, then what I'm really looking for is the true difference in proportion. Okay? And this would tell me something different. Also, I would take a sample from the men and then from the women and let that help me decide if there is a real difference. Now we know statistically, even if they were exactly the same, they should be slightly different from each other. So mathematically, that's what we're calculating is if we assume they were exactly the same, how far apart would be very obviously too far apart. So that's evidence that they are in fact different. Okay, the name of this test is, as you guessed, a two sample z-test. And that's what we're studying in this chapter. Well, what are we trying to decide? We're trying to find the difference between the two. Now, you can also do a confidence interval, so a two sample z-interval. Interval. So again, chapter 8, I would have the word interval. Chapter 9, I have the word test. So check our conditions. That's going to be the same for either the interval or the test. We've been working on those, correct? So we check our randomness, right? And we're looking for whether or not that one sample you took was a random sample. Here, if we notice, we saw quite a few, either each one of them was a random sample and they were independent of one another. So random samples, plural. Or we also saw an experiment where we separated the two groups, the yawn and the non-yawn seated, and those were randomly assigned. So this is somewhat new. We could have, but we didn't really explore that last chapter. So now we explored here as well, if it is a random sample, then are each of the samples properly sized, right? So you want to make sure that your sample 1 is less than 10% of your population size 1, and your second sample is less than 10% of your second population size. And we've got to do a large counts, right, to check for normal. So to check for normal, we need to do a large counts. And we noticed there was some weird stuff happening. In this time around, because we used that p hat combined, that was different, right? So when we look here, when we just have one sample, this is pretty much the same, right? We want to test for this 10% condition. And we're really looking for our sample size to be less than 10% of our population. So when I check for normal, I check just like I always would for large counts. And you would take n times p and find out if it's greater than 10, and then n times 1 minus p, figure out if it's greater than 10. What's different when I do an interval? So I'm going to make a little note here that for my confidence intervals, I'm going to use in this setting p hat instead. Okay, so hopefully that helps us kind of keep it track in our minds. So what do I do for large counts? Well, if I'm doing large counts, we go n1 times p1 greater than 10, and n1 times 1 minus p1 greater than or equal to 10. And my second sample, second proportion, second sample, 1 minus my second proportion. That was what we used when. That was used when we used for our confidence interval. So what changed? Well, notice when we did our significant test or stat test, the test for significance, notice we used the p hat combined instead. Okay. So how does the calculator calculate? If it is in fact random 10% and it is normal, then that would mean that I would be able to use the mean of the sampling distribution and the standard deviation of the sampling distribution in order to create these normal graphs, right? So what formulas are the calculators using? Well, the mean of your sample would just be your p, the one you're trying to make an inference about. And the mean difference that you're trying to approximate, right, should just be equal to your parameter. Okay, so how does the calculator calculate your standard deviation? To find the standard deviation of your sample, it should be just your p, 1 minus p over n, take the square root of the whole thing. And if you're taking a difference between two means, notice it has to use this idea of you can add variances. So that would mean you can take the square root of the whole thing, and each one of these are variances. Remembering that, I'm going to use p combine when I'm doing a significance test. But I didn't use it in the last chapter. So what do we have here? Well, our formulas for our confidence interval from last time was generically our point estimate plus or minus our margin of error. Do you remember that? PE plus or minus MOE. How did we calculate this? Well, our point estimate was just merely our p hat plus or minus our z star times the quantity, and we used our p hat. We didn't know p, so we had to use our p hat to approximate, doing our confidence interval. This amount is called our standard error of our sample proportion. What does the calculator use to find our confidence interval? Well, when I have a difference in proportion, I take my sample, and that's our point estimate, plus or minus our z star times the quantity, p1 hat, 1 minus p1 hat, over n1, plus p2 hat, 1 minus p2 hat, all over n2. Okay, so now that we reviewed the last chapter and compared it to this new one, let's really dig in. What are our formulas for our significance test? So again, generically, we have our test statistic, which is usually called our Z, has to be equal to our statistic minus our parameter all over whatever our standard deviation is. So that's A minus P over S, AP statistic. A Z-score value is whatever you actually got, that's your sample. What would you predict to get, that's your parameter. And S is your standard deviation. So the calculator here finds Z, our actual value is our P hat. We predict to get the parameter, and we put it over our standard deviation. P, 1 minus P over N, and take the square root of the whole thing. This is what we use when we have one sample. When we have two samples, notice we're using this P combined, right? So our actual value, what did you actually get of a difference? Minus, you'd assume there isn't a difference, so that's usually 0, that number right there. And then our standard deviation, where we combine these. P combined, 1 minus P combined over N1. Remembering that for our significance test, this P combined value is calculated by combining the people that said yes in both the groups and combining how many people you asked in total. So combining the number of people you asked in both groups, and that's where that number comes from, the calculator. Your calculator will do all of this anyway, but this helps us answer multiple choice questions and also understand how the formulas work with the general premise of the chapter. Thanks, guys. See you soon.